Chapter 6 of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Substance and Beyond. Science has ascribed to Substance certain characteristic qualities which it calls properties. It divides these properties into two classes, viz. 1. Molecular properties, sometimes called physical properties, and 2. Atomic properties, sometimes called chemical properties. Molecular properties are those which may be manifested by Substance without disturbing the molecules, and consequently without affecting the kind of Substance. Atomic properties are those which concern the atoms when free from molecular combination, and which consequently cannot be manifested without changing the kind of Substance. Science before long is likely to add a third class of properties, namely corpuscular properties, relating to the corpuscles or particles of radiant matter, but so far it has not had the opportunity to sufficiently observe these qualities, except in a general way. There are certain general properties that seem possessed by both mass, molecules, and atoms, and probably by corpuscles. These general properties are as follows: Shape, that property whereby Substance takes up room. This property manifests in three directions, called dimensions of space, namely, length, breadth, and thickness. Weight, that property whereby Substance responds to gravity. Weight is simply the measure of the attraction. Impenetrability, that property whereby two bodies of Substance are prevented from occupying the same space at the same time. A nail driven into a piece of wood simply pushes aside the molecules and occupies the space between them. Substance is never actually invaded, or its actual territory occupied by other Substance. Indestructibility, that property whereby Substance is prevented from being destroyed or annihilated. Although the forms of Substance may be changed or transformed into other forms, still, Substance in itself is not destroyed, and cannot be under the existing laws of the universe. Mobility, that property whereby Substance responds to imparted motion. We shall notice this property in our consideration of motion. In addition to the motion of the mass, and the movements of molecules and atoms in response to its attraction, there is another form of motion constantly going on, without reference to the attraction or impressed motion of the mass. The molecules of all bodies are always in a state of rapid motion, called vibration. In solids this vibration is short, being restrained by the close cohesive position of the molecules. But in liquids, the molecules being further separated, the vibration is far more rapid, and they move around and slide over each other with comparatively little resistance. In gases and vapors the molecules have a splendid field for motion, and consequently vibrate in wide fields and orbits, and dash around with the greatest velocity. The atoms also are believed to vibrate rapidly in accordance with their own laws of vibration, and the corpuscles are believed to far excel the last two mentioned particles in intensity, rapidity, and complexity of their vibrations, as we shall see a little later on in the book. All Substance is in constant motion and vibration. There is no rest in Substance. Inertia, that property whereby Substance may not move unless in response to imparted motion, nor terminate its motion when it is once imparted, except in response to some other manifestation of impressed force. Science holds that this impressed force or imparted motion must come from without, but the writer holds that force may also be expressed from within, as may be seen by reference to subsequent chapters of this book. Attraction, that property whereby particles or bodies of Substance 1. Draw other particles or bodies toward themselves, or 2. Move toward other particles or bodies, or 3. Are mutually drawn together. This property manifests in four forms, generally referred to as separate and distinct from each other, but which the writer believes to be but forms of the same attractive power, and which he believes to be a mental process, at the last analysis, a revolutionary claim which will be supported by argument in later chapters of the book. These three forms of attraction are known as 1. Gravitation, 2. Cohesion, 3. Adhesion, and 4. Chemical Affinity, or Chemism. We are invited to consider them briefly at this point, further investigation being reserved for our chapters on Motion and Dynamic Thought. Gravitation. This term is usually applied to the attraction between masses of substance, such as the sun, the earth, and masses of substance on or about the earth's surface. However, Newton, who discovered the facts of gravitation, states the law as every particle of matter in the universe attracts every other particle, etc. Cohesion. This term is used to indicate the attraction between molecules by which they are combined into masses or bodies. Cohesion causes the molecules to unite and cling together, thus forming the mass. Adhesion. This term is used to indicate the attraction between masses which causes them to stick together without a cohesion of their molecules. Adhesion operates through the adjacent surfaces of the two masses. It may be considered as a lesser form of cohesion. Chemical Affinity, sometimes called chemism or atomic attraction. This term is used to indicate the attraction between the atoms by which they combine, unite, and cling together, forming the molecule. Science has before it the task of naming and classifying the attraction between the corpuscles by which they combine and form the atom. But whatever the name, it will be seen that it represents but another manifestation of attraction. Arising from molecular attraction or cohesion are several properties peculiar to masses having molecules, and resulting from the tendency of the latter to resist separation. We had better consider them briefly, in order to understand the power of molecular attraction and its incidence. Porosity. This property indicating the distances observed by the molecules in their relation to each other, which varies in different kinds of substance. All substance is more or less porous, that is, has more or less space existing between the molecules. The degree depends upon the closeness. Compressibility and expansibility, sometimes mentioned as properties, are but results of porosity. Elasticity. That property whereby bodies resume their original size and form after having been compressed, expanded, or bent. The result is caused by the inclination of the molecules to resume their original positions. What is sometimes called plasticity is merely the reverse of elasticity, and denotes a limited degree of the latter. Hardness. That condition resulting from molecular attraction resisting the forcible entrance and passage of other substance between the molecules. Tenacity. That condition resulting from molecular attraction resisting the forcible pulling asunder or tearing apart of the mass. This condition sometimes is called toughness. Malleability. That condition resulting from molecular attraction resisting the forcible separation of the mass by pounding, hammering, or pressure. The resistance is passive, and consists of the molecules allowing themselves to assume a spread out formation rather than to be forced apart. Ductility. That condition resulting from molecular attraction resisting the forcible separation of the mass by a drawing out process. The resistance is passive, and consists of the molecules allowing themselves to be drawn out into a formation of the shape of wire or thread, rather than to be pulled apart. In any of the above cases we may intelligently and with propriety substitute the words molecules by means of cohesion, resisting, etc., for the terms above used, molecular attraction, resisting, etc. All masses of substance, probably molecules as well, are capable of expansion and contraction, both phenomena in fact and in degree resulting from the relation of the molecules. Contraction is a crowding together of the molecules; expansion, a getting apart of them. Density, the amount of substance in relation to a given bulk. Volume, the size or bulk of a body of substance. Mass, besides being used to designate a body of substance composed of two or more molecules, the term mass is used to designate the total quantity of substance in a body. An application of the above terms may be seen in the following illustration. A quart of water occupies a certain space. and has a certain volume, mass, and density. Convert the same mass of water into steam and it expands to a volume of 1,700 times that of water, but as no molecules have been added the mass remains the same. But as a quart of steam weighs 1,700 times less than the same volume of water, the density of steam is 1,700 times less than that of water. As the volume of a given mass increases, the density decreases in the same proportion, but the mass remains the same. Mass therefore has two factors, i.e., volume and density. The density of a mass is determined by the weight of a certain volume of it. The above consideration of the properties of Substance dealt only with the molecular properties, or physical properties, as they are sometimes called, that is, with properties depending upon the existence of the molecules. When we consider the molecules as being composed of atoms, and when we consider the processes whereby these molecules are built up of, or broken down through the separation of atoms, we come to the subject of atomic properties, or chemical properties, as they are often called. The atomic properties of Substance consist principally in the power and manifestation of motion, in the direction of combination, separation, and the complex motions resulting from the same. This motion is manifested by reason of atomic attraction, sometimes called chemical affinity, which we shall consider a little later on in this chapter. Atomic principles, as above mentioned, are best illustrated by a reference to chemical changes, and we shall now examine the same. And the better way to consider chemical changes is by comparing them with physical changes, or changes of the molecules. Some physical changes in Substance are brought about by heat, which tends to separate the molecules, or rather to allow them to spread out away from each other, so long as the high temperature is maintained, the degree of their nearness being influenced by temperature. Other physical changes are produced by outside forces, separating the molecules to such an extent, to such a distance, that their cohesive force is lost, and the solid matter is said to be broken, or even reduced to dust. Other physical changes are brought about by electricity, causing the molecules to separate and disintegrate. Chemical changes, as distinguished from physical changes, do not involve or deal with molecules, the action being solely upon the atoms of which the molecules are composed. Physical changes separate molecules from each other, while chemical changes destroy and break up the molecule, so that its identity is forever lost, its atoms therefore either existing free-form combinations, or else recombining with other atoms and forming new combinations. Chemical changes are occasioned by either physical or chemical agencies. The physical agencies generally employed are heat, electricity, light, pressure, percussion, etc. The principle of chemical changes is that the atoms are possessed of, and subject to, what is called atomic attraction, or chemical affinity, which may be defined as an attraction or love existing in varying degrees between atoms. This affinity causes atoms of one element to seek out and ally themselves to atoms of another element, the element of choice or preference being strikingly in evidence. Atoms of different elements form marriages and cling together in harmony until perchance, by some physical or chemical agency, the molecule is brought in sufficiently close connection with another molecule composed of different elemental atoms, when, alas, one of the atoms of our molecule finds that it has a greater affinity for some other elemental atom in the second molecule, and lo, it flies away, leaving its first partner and seeking the new charmer. Divorce and remarriage is a common thing in the world of atoms. In fact, chemistry is based upon these qualities. Physical and chemical changes gradually transform solid rock to earth or soil. Disintegration, by the action of changes in temperature, rains, and atmospheric influences, and other physical changes, have slowly worn down the rocks into dirt, gravel, clay, loam, etc., and decomposition by chemical change that set the atoms free from their combination has aided in the work. There is no rest in the world of Substance. Everything is changing, constantly changing. Old forms give way to new, and these, grown old while being born, are in turn replaced by still newer, and on endlessly. Nothing persists but change, and yet nothing is destroyed, although countless forms and shapes have succeeded each other. Substance is always there, undisturbed and unaffected by the varieties of forms it is compelled to undergo. Masses may change, and do change. Molecules may change, and do change. Disintegration and decomposition affect both, and bring to them the death of form. But their substance endures in the atom. Atoms may change and decompose, or undergo whatever change that is their fate, and still the corpuscles, or what lies beyond the corpuscles, will remain. The atom was once regarded as eternal, but now even it seems to be capable of dissolving into some finer division of substance, and perhaps still finer subdivisions await it. That familiar form of substance that we call earth, dirt, soil, etc., is but the result of disintegrated rock, which has crumbled and lost its former form through the action of air, water, and atmospheric influences. And the rocks themselves, from which the soil came, were at one time a sea of melted, flowing liquid substance, somewhat resembling volcanic lava. And this melted rock is thought to have been condensed from the same principles in the shape of vapor that existed in the early days of our planetary system. Vapor, gas, liquid, semi-liquid, solid rock, soil, the substance unchanged, the forms totally unlike. Helmholtz estimates the density of the nebulous vapors of Substance as being so rare that it would take several millions of cubic miles of it to weigh a single grain. Oh, Nature, what a wizard thou art! We have spoken of air and water in a former chapter, and their constituent atoms have been named. And from these three great reservoirs of Substance, the earth, the air, and the water, are obtained all the material that goes to form the bodies of the animal and vegetable kingdoms. The plant draws its nourishment from the soil, the air, and water, and in its wonderful chemical laboratory is able to transform the elements so drawn from these sources into a substance called plasm, which consists principally of carbon, oxygen, nitrogen, and hydrogen, being nearly identical in composition to the white of an egg, and which constitutes the basis of animal and plant bodily structures. All the material of the physical bodies of men, animals, and plants are but forms of plasm. The animals and man obtain their nourishment directly or indirectly from the plant body, and so at the last we are seen to draw from the soil, air, and water all our bodily nourishment, which we convert into bodily structure, bone, muscle, flesh, blood, veins, tissues, cells, etc. And the chemical atoms of our bodies are identical with those in the rock, the air, the water. And so you see the universality of Substance and its countless forms and appearances. Chemistry resolves Substance back into about 75 simple substances, of which atoms are the units, which simple substances are called elements. From these elements, by their atoms, all other substances are formed by combinations, the number of such possible combinations being infinite. An element, in order to be an element, must be a simple substance, that is, must be incapable of further analysis into some other elements. The 75 elements now recognized by science have never been resolved into other elements by chemical analysis, and therefore are accepted as simple. But it is true that other substances that were formerly considered as simple elements were afterward decomposed by electricity and found to consist of two or more simpler substances or elements. Thus new elements were discovered, and old ones discarded as not elemental. And this fate may be in store for a number of the elements now on the list, and many new ones may be discovered. For a long time science was endeavoring to trace all elements back to hydrogen, the latter being considered the ultimate element, and its atoms composing all the other atoms under varying conditions, etc. But this theory is now almost abandoned, and science rests on its list of 75 elements, the atoms of which are composed of electrons. Some have hazarded the theory that the elements were all forms of ether (see next chapter), their apparent differences resulting merely from the varying rate of vibration, etc. And in fact such theory was about finally adopted as a working hypothesis until the discovery of the corpuscle. Everything in Substance now seems to be moving back to the corpuscle, as we shall see a little further on. The following is a list of the principal elements known to science today: aluminum, antimony, arsenic, barium, bismuth, boron, bromine, cadmium, calcium, carbon, chlorine, chromium, cobalt, copper, fluorine, gold, hydrogen, iodine, iron, lead, magnesium, manganese, mercury, nickel, nitrogen, oxygen, phosphorus, platinum, potassium, radium, silicon, silver, sodium, strontium, sulfur, tin, zinc. Of the above, hydrogen is by far the lightest in weight. In fact, it is used as a unit of atomic weight, its weight being marked 1 on the scale, gold 197, lead 207, silver 108, oxygen 16, nitrogen 14, iron 56. The discovery of the corpuscle or electron rudely shattered the vortex ring theory of the origin of the atom, and now, instead of the atom being regarded as a vortex ring in that hypothetical, paradoxical absurdity, the Ether, it is believed to be composed of a vast number of tiny particles called corpuscles, as we saw stated in our last chapter. These corpuscles seem to be the last thing in Substance, its last known state of refinement, and already it is being proclaimed as the last sought for Primal Matter or Ultimate Substance. Whether or not a still finer state of Substance will be discovered, science is unable to say, but thinks it unlikely. But we must not overlook the old occult teaching indicating a state of Substance so fine that it is imperceptible, and only recognizable as apparently Free Force, its covering or vehicle of Substance not being evident. This would seem to indicate a still further refinement of Substance, although perhaps the corpuscle or electron will answer to fill the bill in the case. As to the corpuscle being Primal Substance, it must be admitted that its advocates have presented a very strong case. One of their most important points is that although molecules differ very materially from each other according to their kinds, and while atoms likewise manifest very plainly their kind, the corpuscle seems to possess only one kind, no matter from what form or kind of substance it is thrown off. Just think what this means. It means that the finest particles of gold, silver, iron, hydrogen, oxygen, and all the rest of the elements are composed of identically the same material, and exhibit no differences in kind. The elements are no longer simple, all Substance is one, at the last analysis. The corpuscles seem to possess the same mass, to carry the same charge of electricity, to act precisely the same, irrespective of their source. No difference in size, mass, or character, as in the case of the atom. All are identical, save in the rate of their vibration at the time of observation, which is simply a matter of more or less motion. Space seems to be flooded with these tiny particles, these units of Substance. They stream from the sun, the stars, and every body highly heated. Likewise, they stream from the bodies of highly electrified Substance. Groups of these corpuscles, absolutely identical in nature, size, mass, etc., constitute the atoms of the 75 elements, the kind of element seemingly being dependent upon the number and arrangement of the corpuscles and possibly their rate of vibration. Every atom is like a great beehive with a swarm of corpuscles vibrating, moving around each other, and upon their own centers. And if by the action of intense heat, transmitted or caused by interrupted motion, or if by a strong electric charge, some of these corpuscles are detached from the atoms, or possibly an atom broken up, they fly off through space at a marvelous speed of many thousand miles an hour. So we see that these wonderful corpuscles look very much like Primal Matter or Ultimate Substance, the stuff out of which Substance is made. And taking you back to the chapter on the Universality of Life and Mind, the writer would remind you that in their motions and evident attraction, etc., these corpuscles evidence the same "life and mind" that we observed in the molecules and atoms. It must be so, for what is in the manufactured article must be in the material of which the article is made. And so, even here, Life and Mind have not escaped us, nor will it in the Ether. And speaking of the corpuscles as manufactured articles, we are reminded of Herschel's thought about the atoms, when they were regarded as primal matter and likely to be uniform and, at the end, of one primal substance. Although Herschel's conception does not now apply to the atoms, it may be transferred to the corpuscles. Herschel thought that the fact that the particles of Substance were likely to be found to be uniform in size, and identical in nature and characteristics, indicated that they might be akin to manufactured articles, turned out from the same great machinery of creation. This idea would indicate that the Creator applied the rules of careful manufacture to the manufacture of the particles, the uniformity operating in the direction of 1. Economy of material, 2. Utility through interchangeability, replacing broken or discarded parts, etc., and also 3. Conformity to a standard of size, quality, etc. The thought is interesting, and is mentioned here for that reason. It is not affected by the supposition that there may be a still finer and rarer form of Substance from which the particles are manufactured. In fact, the idea of Herschel, if closely analyzed, would seem to indicate some such raw material from which the articles